January 9, 1863, 30 feet beneath Farringdon Street, London. The acrid smoke couldn't hide the smirk on French railway engineer Émile Beaumont's face as he watched the ungainly locomotive belch clouds of sulphurous steam into the brick-lined tunnel. The veteran of the Paris-Rouen line studied the soot-blackened passengers emerging from the world's first underground railway's official trial journey with barely concealed amusement. Above them, the Metropolitan Railway's first day of operations saw 30,000 passengers crammed into gas-lit wooden carriages, hauled through tunnels by coal-fired locomotives, breathing air thick enough to see. To European engineers accustomed to the elegant elevated railways and surface lines of Paris and Berlin, this subterranean monstrosity appeared almost comical. Narrow tunnels barely wider than the trains themselves, stations illuminated by flickering gas lamps, platforms where passengers choked on engine smoke, and ventilation shafts that turned London streets into fumaroles. However, what Beaumont didn't know, and what none of the European engineers touring this British curiosity could have imagined, was that they were witnessing the solution to every major city's greatest nightmare. Within 40 years, these smoke-filled tunnels would transform from objects of derision into essential infrastructure, their tunneling techniques becoming the blueprint for urban transportation worldwide. The mathematics of urban survival were already embedded in those sooty bricks. 40,000 passengers per day capacity, 50% reduction in street-level congestion, the ability to move 10 times more people than surface transport in the same corridor. Every major capital would face the same existential choice: dig or suffocate. The transformation began that January morning when Charles Pearson's impossible dream, a railway beneath the streets, proved it could work. The solicitor for the City of London, who had died just before seeing his vision realized, understood what his critics didn't, that the future of cities required conquering the third dimension. The Metropolitan Railway represented a radical departure from conventional urban planning philosophy. While European cities had pursued elegant boulevards and regulated surface transport, London had created something unprecedented: a parallel transportation network operating in a realm previously reserved for sewers and crypts. Among the skeptical observers that opening day were engineers who would become converts, future underground railway pioneers, whose cities would desperately need solutions to the same problems choking London. But on January 10, 1863, they were critics facing what appeared to be an expensive, dangerous, and uncomfortable failure. The French had been moving people efficiently since the 1850s with their omnibus system. The Germans had their orderly street railways. The Americans were building elevated lines in New York, whilst the British had built a hole in the ground. This story is about how engineering necessity defeated aesthetic preference, how practicality and innovation merged into unstoppable adoption, and how European derision turned to imitation as cities discovered what moving millions underground could accomplish. The Metropolitan Railway had emerged from a Victorian-era crisis. By 1850, London's population had exploded to 2.3 million, making it the largest city in the world. The streets, designed for horse-drawn carriages serving 1 million, were in complete gridlock. Charles Pearson, the city solicitor, proposed the impossible: build railways beneath the streets. "It will be a tomb for the living," critics declared in Parliament. "The tunnels will collapse, burying thousands. The smoke will asphyxiate passengers. The vibrations will crack every building foundation from Paddington to Farringdon." The construction that began in 1860 shocked everyone who witnessed it. Using the cut and cover method, contractors excavated trenches up to 33 feet deep along entire streets, displacing thousands of residents and businesses. The Fleet Ditch, an ancient sewer, had to be relocated. Gas mains, water pipes, and underground infrastructure that nobody knew existed were discovered and rerouted. Engineer John Fowler, who designed the Metropolitan Railway, developed ventilation systems that pumped air through shafts every 100 yards. The locomotives, specially designed by Sir Daniel Gooch, featured condensing systems that theoretically captured steam, though in practice passengers still choked on sulfurous fumes. However, those who rode it discovered something extraordinary beneath the discomfort: speed. The Metropolitan Railway covered the 3.75 miles from Paddington to Farringdon in 18 minutes, journey time that took 45 minutes on surface streets. For Victorian commuters, this was a revolution. Paris watched with superior amusement. The French capital, recently redesigned by Baron Haussmann with magnificent boulevards 120 feet wide, had no need for underground railways. Their street-level transport moved elegantly through the city of light. French newspapers published satirical cartoons showing English gentlemen emerging from underground stations as coal miners, their top hats askew, faces blackened. The first year's operations seemed to confirm European skepticism. Multiple accidents occurred as locomotives collided in smoke-obscured tunnels. A driver was killed when his train struck a tunnel wall. Passengers fainted from the fumes, requiring revival by station staff. The Board of Trade investigated repeatedly. Yet something strange was happening that European observers failed to notice. Londoners kept riding. Despite the smoke, despite the accidents, despite the discomfort, 9.5 million passengers used the Metropolitan Railway in its first year of operation. The economics were undeniable. Profit exceeded projections by 30%. More significantly, when the Metropolitan Railway opened, London's street congestion decreased measurably. Police reports noted 15% fewer traffic incidents in areas served by the Underground. Property values along the line increased dramatically. Suburban areas suddenly became accessible to workers. Berlin scoffed publicly while studying intently. Prussian efficiency demanded thoroughness, and Werner von Siemens, Germany's leading electrical engineer, visited London in 1864. His private report to the Ministry of Transport was sobering. The English approach is crude but effective. They have solved urban transportation's fundamental problem, limited surface area, by adding vertical dimension. The smoke is a technical challenge, not a conceptual flaw. The event that would begin changing European perceptions occurred on November 18, 1890, when London opened the world's first deep-level electric underground railway, the City and South London Railway. It involved something revolutionary that addressed every criticism of the original Metropolitan line. Gone were the coal-fired locomotives and their choking smoke. Electric traction motors, powered by a generating station at Stockwell, pulled trains through circular tunnels bored 70 feet beneath the surface using a revolutionary tunneling shield invented by J.H. Greathead. The tunnels, only 10 feet 6 inches in diameter, were lined with cast-iron rings, a technique that would become universal. The ride was clean, quiet, and smooth. The ventilation was natural, drawing fresh air through station shafts. Most importantly, because the tunnels were so deep, they required no surface disruption during construction. Businesses and residents above remained undisturbed. Henri Fulgence Bienvenu, chief engineer of the Paris Metro project, traveled to London in 1891 specifically to study this new system. What he saw transformed his understanding. He later wrote in his official report, "The English have achieved what we thought impossible. They have created a railway that does not disturb the surface, produces no smoke, and operates with clockwork precision. The electric system eliminates the primary objection to underground travel. The deep tunneling method allows routing beneath any obstacle. This is not merely a railway, it is three-dimensional urban planning." By 1895, London operated 41 miles of underground railway, carrying 100 million passengers annually. The network continued expanding, with deeper tubes reaching areas surface transport couldn't serve efficiently. Businesses located near underground stations thrived. Suburbs boomed. London was demonstrating something undeniable. Underground railways created economic value exceeding their construction costs. Paris faced a crisis by 1895.
The city's population had reached 2.5 million. The beautiful boulevards were in permanent gridlock. Horse-drawn omnibuses couldn't meet demand. The 1900 Universal Exposition was approaching, promising to bring millions of additional visitors. The French government finally admitted what they'd privately known for years. Paris needed what London had built. The authorization came in 1898. The Metropolitan de Paris would use London's deep-level tunneling techniques, electric traction, and station design principles. But French pride demanded innovation. The Paris Metro would be shallower than London's tubes, using cut and cover where possible to reduce costs, and would feature distinctive Art Nouveau station entrances designed by Hector Guimard that proclaimed French aesthetic superiority. Construction began immediately, using a workforce of 4,000 men working 24 hours daily. The engineering borrowed heavily from London: Greathead's tunneling shield design, cast-iron tunnel linings, electric multiple-unit trains, and platform-edge lighting. French engineers improved ventilation by installing forced air systems and designed stations with ceramic tile walls that reflected light beautifully. On July 19, 1900, the first line of the Paris Metro opened from Porte de Maillot to Porte de Vincennes, just in time for the Exposition. The transformation in French opinion was immediate and complete. Newspapers that had mocked London's mole railway proclaimed the Metro a triumph of French engineering. The fact that it was essentially London's system with French decoration went unmentioned. Gustav Kemmen, Berlin's chief city planner, toured the Paris Metro in September 1900. His report to the Berlin Senate was blunt. Paris has copied London and improved the execution. We are now the only major European capital without underground railways. This situation must be rectified immediately, or Berlin will be strangled by its own success. Berlin's underground railway, the U-Bahn, received approval in 1896, but construction had been delayed by political disputes. The Paris Metro's success ended all debate. Using elevated construction in outer districts and underground tunnels in the city center, Berlin's system opened in 1902. Like Paris, it borrowed London's fundamental technology while adding German innovations: better signaling systems, standardized train designs, and efficient station layouts. The Germans added something else: comprehensive integration with surface transport. Unlike London and Paris, where underground railways competed with surface lines, Berlin designed its U-Bahn to complement trams and buses. The result was a transportation network more efficient than any European capital had achieved. By 1905, London, Paris, and Berlin all operated electric underground railways. The transformation from mockery to universal adoption had taken exactly 42 years. Budapest opened its underground railway in 1896, technically the second in Europe after London, but used a shallow cut-and-cover design beneath Andrassy Avenue that Europeans didn't consider a true underground. The Hungarians protested this dismissal, noting their system was fully electric from opening, predating London's electric lines.
The true revelation of underground railways' power came during the First World War. London's underground moved millions of workers to munitions factories, transported troops to ports, and sheltered civilians during air raids. The tubes, dismissed as expensive luxuries in peacetime, proved essential to survival in war. Paris's metro performed similar service, while Berlin's U-Bahn kept the German capital functioning despite blockades. After the war, underground railway construction exploded globally. Madrid opened its metro in 1919, using Spanish engineers who had studied in London and Paris. Barcelona followed in 1924. Moscow began planning its legendary metro in 1925, sending engineers to London to learn tunneling techniques. The Stockholm Tunnelbana opened in 1950, but Swedish engineers had visited London underground facilities repeatedly during the 1930s, learning operational procedures and safety protocols.
The distinctive Stockholm system, with stations carved from bedrock and left as natural caverns, was aesthetically unique but technically derivative of London's deep-level principles. The adoption across every continent followed predictable patterns. Tokyo opened Asia's first subway in 1927, after Japanese engineers spent 3 years studying London's system. New York, which had dismissed underground railways as European foolishness, opened its comprehensive subway in 1904 using British consulting engineers. The statistics of global adoption were staggering. By 1930, 15 cities operated underground railways. By 1950, 30 cities. By 2000, over 150 cities worldwide. Every system, regardless of local variations, used fundamental technologies pioneered in London. Tunnel boring methods, electric traction, platform design, signaling systems, ventilation engineering. The Paris Metro, despite French protests, acknowledged its debt implicitly. When the Metro expanded after World War II, French engineers used British tunneling equipment and consulted London Transport on deep-level construction. The Art Nouveau entrances remained distinctively French, but beneath them ran technology perfected in London. Perhaps the ultimate vindication of London's underground came with Moscow's metro, when Stalin demanded the world's most magnificent subway in 1931. Soviet engineers were sent to London and Berlin to learn construction techniques. The resulting Moscow Metro, opened in 1935, with its palatial stations and communist iconography, was built using British tunneling shields, German electrical systems, and operational procedures copied from London Transport's manual. The beautiful marble halls and ornate decorations were Soviet, but the engineering beneath was London's gift to the world. At the International Congress of Underground Railways held in Paris in 1930, delegates from 40 cities gathered to discuss underground transportation. The opening address was given by Lord Ashfield, chairman of London Transport. His remarks, recorded in the Congress proceedings, captured the transformation. 67 years ago, we opened the world's first underground railway. European observers called it a disaster, a smoke-filled tomb, an expensive failure. We heard predictions that London would abandon this foolish experiment within years. Instead, every city represented at this Congress has built, is building, or is planning underground railways based on principles we established in 1863. The technology has improved dramatically. Our early passengers endured smoke and discomfort we would not tolerate today. But the fundamental insight that cities must build vertically to survive horizontally has proven universal. Paris, Berlin, Madrid, New York, Tokyo, Moscow, all have discovered what we learned beneath Farringdon Street. The future of cities is underground. The audience, including representatives from cities that had once mocked London's underground, applauded without irony. By 1963, London's underground carried 675 million passengers annually through 252 miles of tunnels. The smoke-filled Victorian Railway had evolved into an electric system moving 4% of London's population daily. The original Metropolitan Railway, still operating, had been cleaned, electrified, and integrated into a network serving every part of Greater London. The economic impact was measurable. Studies demonstrated that property within 500 meters of underground stations commanded 10 to 15% price premiums. Businesses located near stations reported 20% higher foot traffic. The underground had created its own geography of value, reshaping London's development patterns. More importantly, London without the underground was unimaginable. The 8.6 million residents of Greater London by 1960 could not have been sustained by surface transport. The city would have strangled on its own congestion, forcing population dispersal or economic decline. The Underground had made modern London possible. The Paris Metro, which opened 37 years after London, and with significant advantages in technology and learning from British mistakes, acknowledged its debt explicitly in 1963. At ceremonies marking the centenary of Underground Railways, RATP chairman Pierre Hombart stated, "We built a more beautiful system, but we built it because London proved Underground Railways worked." The smoke-filled Metropolitan Railway of 1863 was crude by modern standards, but it showed the way forward for every city in the world. German Transportation Minister Hans-Christoph Seebohm, speaking at the same ceremony, was more direct. "We called it a hole in the ground. We were wrong. It was a window to the future." The technical specifications revealed London's pioneering role in technologies now universal. The 4-foot 8.5-inch standard gauge, adopted globally, came from British railway practice. The platform height of 3 feet above rail level became an international standard based on London Underground's experience. The electric system voltage of 630 volts DC, chosen by London's early electric lines, was adopted throughout Europe. Even the signalling systems used worldwide traced ancestry to London Underground's innovations. The automatic train control system, developed after a 1938 accident, became the basis for modern metro safety systems globally. The track circuit block signalling, perfected on the Underground, protected trains on every metro system built after 1920. The ventilation engineering, critical to deep-level systems, originated in London's solutions to smoke removal. The piston effect of trains pushing air through tunnels, initially a problem in steam days, became a feature in electric systems. Engineers calculated airflow based on formulas developed by London Underground's engineering department in the 1890s. Perhaps the most universal adoption was architectural. The distinctive roundel symbol of London Underground, designed by Edward Johnston in 1919, inspired similar geometric symbols for metro systems worldwide. The Paris Metro's M symbol, Berlin's U, Moscow's M, all followed the principle of simple, instantly recognizable geometric marks established by London. Station design principles traveled even further. The tiled walls, initially used in London for fire protection and light reflection, became standard globally. Platform seating arrangements, stairway widths, escalator specifications, all traced to London Underground's trial and error development of what worked for moving millions safely and efficiently. In 1985, at a reunion of international metro engineers in London, former rivals met in professional respect. Roland Rees, former director of Paris Metro, was asked about London's Underground. His response, recorded on video, captured the complete transformation. "We made a mistake in 1863. We saw a smoke-filled tunnel and laughed. The British don't understand elegant transportation, we said. They've buried a railway in a sewer. We were the ones who didn't understand." The British didn't try to build a beautiful railway. They built a practical one, designed around capacity, efficiency, and economics. They understood that in dense cities, the only way to add transportation capacity was to dig. They were right. The first time I rode the Metropolitan line in 1950 as a young engineer, I understood everything. The tunnels that seemed crude were perfectly sized for their purpose. The stations that looked utilitarian were optimized for passenger flow. The signaling that appeared simple was brilliantly effective. It was an engineer's railway, built to move millions, not to win beauty contests. But what really impressed me was realizing that Britain built the first underground railway with no examples to follow, no proven techniques, no certainty it would work. They innovated everything: tunneling methods, ventilation systems, station design, operational procedures, all from nothing. That's why every city that built underground railways after London came here first to learn. We added art and decoration. We improved the technology, but we didn't invent underground railways. London did that. And despite 150 years of development, the fundamental principles we use today, deep tunneling, electric traction, high-frequency service, integrated networks, were all established here beneath these streets. The Underground's design represented Victorian engineering philosophy perfectly. Build it strong, build it to last, and worry about beauty later. Every component was over-engineered. The tunnels could support loads far beyond train weight. The electrical systems had multiple redundancies. The ventilation could handle twice the passenger density of typical operations. This conservative design proved prophetic. London Underground's oldest tunnels, built in 1863, still operate today. 161 years of continuous service. The Victorian engineers who designed them for horse-drawn omnibus passengers couldn't have imagined modern ridership levels, but their excessive safety margins made adaptation possible. The economics told an even more compelling story. Every pound invested in London Underground returned £3 in economic activity. Property development, business growth, and reduced congestion created value far exceeding construction costs. Cities that delayed building underground railways paid increasing costs as congestion worsened, eventually spending more to build systems they should have constructed decades earlier. Analysis of European capitals demonstrated this clearly. Paris, building its metro 37 years after London, spent 40% more in inflation-adjusted costs because of higher property values and denser surface infrastructure requiring expensive rerouting. Berlin, waiting 39 years, faced similar cost inflation. Cities that waited until the 1950s paid 300% premiums for rights of way that would have been cheap in 1900. London's early adoption, mocked at the time, proved economically brilliant. The city secured corridors beneath streets when land was cheap, established networks before surface infrastructure became complex, and reaped benefits while competitors paid congestion costs. Even after the war, some cities maintained that underground railways were unnecessary luxuries. Los Angeles, with its extensive freeway system, declared itself too spread out for subways in 1960. By 2020, facing gridlock, Los Angeles was frantically building the underground railway system it should have constructed 60 years ago, at costs per mile exceeding $300 million. The psychological impact was complete. City planners who in 1863 considered underground railways dangerous extravagance treated them by 1963 as essential infrastructure, as fundamental as water systems and sewers. Dense urban development without underground transportation became unimaginable. At the Institution of Civil Engineers in London, a preserved section of original Metropolitan Railway tunnel sits among other engineering artifacts. Its cast-iron support brackets show Victorian manufacturing quality. Below the display is a quote from an 1864 Parisian newspaper translated from French. The English have built a railway in a tunnel filled with smoke where passengers arrive half suffocated and completely begrimed. This expensive failure demonstrates British engineering stubbornness. Paris will never require such barbarous transportation methods. Next to this quote is a modern photograph of Paris Metro Line 1 operating beneath the route of Haussmann's elegant boulevards, moving 50,000 passengers per hour, 10 times the capacity of those surface streets. The Metropolitan Railway entered operation as an object of derision and transformed urban transportation globally. In between, a smoke-filled tunnel beneath Farringdon Street rewrote the rules of city planning and proved that the future belonged to those willing to dig. European engineers had laughed at the ungainly British Railway in January 1863. By 1963, there were no major European capitals without one. The Underground had proven its case, and every city on Earth faced the same choice: dig or strangle in congestion. The steam had cleared, the tunnels had multiplied, and cities everywhere had learned what London discovered beneath its streets, that civilization's future grows downwards as much as upwards.